Good morning, class, and welcome to this lesson on Momentum 6, an inelastic collision example. Okay, so today we're going to be able to solve for the initial speed of an object that participates in a completely inelastic collision. I usually don't do a lot of math examples on these, but I wanted to do this one because I think it is complicated and worth looking at and practicing. So let's take a look at an example. This is going to be a ballistic pendulum. A ballistic pendulum. And what's happening in a ballistic pendulum is a bullet is being fired. A bullet is being fired into a block. Okay, so this is before. It's going to lodge itself into the block and swing the block forward. Inside the block now, and based off the height, how high this goes, we can determine how fast the bullet was going. This is an actual device, and this is what people use to figure out how fast bullets are being fired out of a gun. Okay? So it's really simple. You shoot a block. If you know how high it goes, you know how fast the bullet's going. So this is a completely inelastic situation. The objects are totally stuck together. Okay? So let's take a look at what we're going to do first. We are going to set up an equation. We know that in a completely inelastic collision that the initial momentum is going to equal the final momentum. So that means m1 v1 initial plus m2 v2 initial equals m1 v1 final plus m2 v2 final. Now this is completely inelastic, so I'm gonna modify this. I'm gonna manipulate this around here. Okay, we know that the box, I'm gonna call the bullet object 1, the box object 2, and we know that this box is not moving before they hit, so that's already 0. And we know that v1 final equals v2 final. These both are moving at the same speed after they hit. So this equation is going to become m1 v1 initial equals m1 plus m2 times v final. Okay? That is because if this is the same as this, I've factored it out. And it's just m1 plus m2 times v final. Okay? There's no need to separate v1 final and v2 final because they're both the same object. So this is going to be our initial equation, and we are trying to solve for the initial speed. Okay? So we're looking for this. That means we're going to divide by m1. So v1 initial equals m1 plus m2 times v final over m1. And I forgot to mention this. The bullet weighs, the mass of the bullet is 0.01 kilograms. The box is 2.50 kilograms, and the bullet is moving at a, and all we know is that this box raises up 0.650 meters. 0.650 meters is the change in height. So that's all we know. Okay, so let's go to the next page. Let's rewrite that equation real quick. v1 initial equals m1 plus m2 over m1 times v final. Okay, let's change the color here. And let's do another equation. Now, we've already did conservation of momentum. Now let's do conservation. Let's do now conservation of energy. Well, we know that the kinetic energy of the bullet initially equals the potential energy at the end. We know that the only thing that in this situation here, if we draw it again, all the kinetic energy here converts into potential energy here. Okay? So that means 1/2 mv squared equals m GH. Sorry, I had a moment. Okay, I messed up this equation a little bit. We are looking at the point. We are looking at the point right when the bullet enters into the box and it starts moving. This is all kinetic and this is all potential. So this is actually 1/2 m1 plus m2 v squared, and this is m1 plus m2 g h. Okay, so you already will probably notice that these cancel out. So we have 1/2 v squared equals g h. And this v can be solved for by multiplying both sides by 2 and square rooting. So v equals the square root of 2gh. This should look familiar. And this is that value right there. So if we go back, v1 initial equals 0.01 kilograms plus 0.250 kilograms over 0.01 kilograms, and this is going to be multiplied by, I messed that up a little bit, I'm going to change that, and this is going to be multiplied by the square root of 2 times 10 times 0.650 meters, and this is what V1 initial is. Sorry about that. So 2GH, 2 times 10 times 0.650, we get 0.650 from our question. 0.650 meters is the height it was raised. Okay, we have M1, M2, M1, M2, and then M1 at the bottom here. I'm sorry, because of my screen here, I moved 2GH V final, 2GH onto the left side instead of the right side. So sorry about that. But we end up getting V1 initial is equal to, what's my answer? 896 meters per second. So this is an example of an inelastic collision. In an inelastic collision, we know that initial momentum equals final momentum. We were able to manipulate the equation, so this is the one we're working with. However, in this equation, we have two variables and two unknowns. We have two unknowns, V1 initial and V final. And then so we had to use our conservation of energy. We had to use kinetic energy and potential energy because it is an inelastic. It is an inelastic collision, and because it's an inelastic collision, we canceled out, we solved for V, we plugged back into our original equation, now we only have one unknown and we have to solve. So you need to understand as a student that if it is an inelastic collision, you have two equations in mind. You have kinetic, you have the conservation of energy equation, and you also have the conservation of momentum equation.